teach biology, environmental science, and I also teach a program called Island Pathways that is for, it's a small group of students that really need hands-on environment and a community building environment in order to stay in school. And a lot of them are really involved with fishing, and so we're a big part of our program is the Eastern Maine Skippers program, if you've heard of that before. This is my third year teaching at MDI High School, and when I was part of the pilot program, I was a first-year teacher at this high school, and I was throwing things together. I had seen Dr. Stanton's presentation at the Science Cafe, and I thought it was really, really cool, and I wanted to give my students hands-on projects. So I contacted Jane and Anna, and I kind of got involved before I knew like what I was going to be teaching with Island Pathways. And part of the Island Pathways program is that we're supposed to respond to students' interests. So we're constantly flying by the seat of our pants, which is what happened with this project too. So in the fall, we tried to have students collect data. I had my students put together packets with the water quality testing information and little bottles. We handed them out to other students in the school, but hopefully you can learn from our mistakes. We didn't attach any sort of assignment to those, and there was no sort of repercussions if you didn't return your water test. So we ended up with 5 tests, I think, returned out of like 100 distributed. So that was definitely a learning experience. I ended up having students just run around throughout the school and collect water samples from all of the faucets and the like water taps so that we could have some data and just see, you know, is there any variation within the school? Maybe we can find, maybe not arsenic, but some other minerals that are in there. So we collected data. We ended up not doing a ton with the data because we just didn't have that much from our school. But we wanted to continue thinking about water quality and arsenic. So later in the spring, I was trying to think about what would be accessible to my students and a hands-on project. And I, like any good teacher, I cheated and stole. And I ended up thinking about the water pitcher filters that had been looked at before, and I was like, oh, you know, that's really accessible to students. It's also something when you're dealing with a low-income community, like they don't want the information if they can't do anything about it, and they really can't access much other than a $20 or $30 filter. So I thought it would be really interesting and also focus on like mitigation and what we can do with some of this data. So this is the presentation that my students ended up putting together, and they did tests on a bunch of different filters. I'll show you the presentation. They could not, this demographic of students really has trouble doing anything outside of school. They all work, they all have trouble with transportation and that sort of stuff. So I ended up presenting this at a community forum that we held here at the Bio Lab, and Sarah also presented there. And I have to say, even though my students didn't present this, I was really, really proud of them for putting it together. And during the lab that we did with the pitcher filters, they were saying things like, I feel like a real scientist, and like, this is really fun. And that's like, a student says that from this demographic, and it's huge. So this is what they put together. So they had to describe themselves and give a little background. They focused on we're trying to do hands-on learning with real-life applications. They were asked to test 6 different filters that I just found on Amazon that were relatively inexpensive. I had gotten some arsenic tests that were expired from Sarah Hall, and so I had those to use, and I also bought a bunch of like generic home water tests from Amazon. And we just looked at whatever those tested. So we looked at arsenic, and they had to explain the water quality concerns. Leading up to their lab, I had done just a short unit on basic chemistry. My goal with these students, because It's a co-curricular program that lasts freshman and sophomore year, and they take it instead of the core courses. So I was trying to replace some of the content that they would be missing from biology and from the Introduction to Physical Sciences. So I wanted them to get some basic chemistry information. We looked at that, and then we looked a little more in depth. We did some readings and discussions about different water quality concerns. It's very superficial, but enough to get them engaged and understanding what they were testing. So they looked at arsenic, hardness, pH, total dissolved solids, and a few other things were part of the test, but the control didn't come up with any of those items in our test, so we just didn't discuss them in the presentation. We got our sample of water from Sarah as well, and it was from someone who was willing to share their well water, who had very high levels of arsenic and knew about it beforehand. So we received water that we knew had a lot of arsenic in it. We ran our tests mostly in our classroom. Students paired up, and each pair had their own pitcher that they got to do all the tests on. So every student had a really hands-on experience with that. And we did the testing over 2 days. And as you can see, I have a math room that I do this in. So, you know, we could do it anywhere. We just needed a sink and some goggles. So the 6 filters that we tested were Wamery, Pure, I don't know how to say it, Brita, Zero Water, Mavia, and EcoSoft. And they kind of had to look at all the benefits of those. And of course, I had my idea about what would work because I'd seen Dr. Stanton's presentation, but I didn't say anything to them because I wanted to see if our results would support his, if we did the tests well. If those arsenic tests weren't if their expiration didn't really mean anything. So we had some really exciting results. We had a control that was about 300 parts per billion, so well over the EPA limit of 10 parts per billion. We had measured, the test was in parts per million, so that's why you see a 0.3 parts per million in our control. I did the control test so that I could be sure that it was valid, although the students did an awesome job. So we found that all of the pitchers reduced arsenic somewhat from that high level, but Zero Water was the only one that reduced it completely. Hardness, we found that Pure was really good at removing or mitigating hardness, and Mavia, we found that pH was reduced slightly by all of the filters, but it really wasn't at a majorly concerning level. It was relatively neutral for all of them. Total dissolved solids, and this is what is shown, like you were saying, there's a little stick that comes with your Zero Water filter. I personally bought one, and I use it all the time. I change the filter all the time. And the little stick that comes with it, it will show you the total dissolved solids. And so we use that to test total dissolved solids. And Zero Water, I mean, maybe they modify it somehow so they look really good. But they clearly were the only ones that took all the total dissolved solids out as well. And I ended up keeping the pitcher that we used for this experiment in my science office, so I have a pitcher at school as well. So we got some exciting results, and the students felt really validated, and they got to tinker with all these cool chemicals and test strips, and because the water test had so many different things it was testing for, including bacteria, it was really fun and really engaging for them. So in our conclusions, we found that the Zero Water filter was clearly the best option for our health, and then we wanted to connect our audience to resources, as well as my students, to outside resources to help mitigate whatever water quality they might have. So that's my presentation, brief and to the point.